Hi everyone, so today we're going to be discussing the rate calculations. Now it is important to note that the gradient or the slope, in other words the slope of the curve, okay, represents the rate of reaction, okay, of reaction. So here, if you look here, at the beginning, at the start of the graph here, this graph represents the relation between product concentration over time, because it is ascending, which means that the concentration of products is increasing, and the concentration of reactants decrease. So whenever you see the graph, the curve ascending, that means that it is a graph showing the concentration of products. Okay, so now here, at the beginning of the graph, you see that the slope is very big, okay? Which means it's very steep, okay? So the gradient here, okay, the steepness of the gradient is greater than the steepness in the gradient of the gradient here, or here, or here, which means that the reaction rate here is faster than the reaction rates here and here and here, okay? So it is very important for you to understand the reason as to why that is. When we talk about the gradient is change of y over change of x. And in this graph here, it is basically the change in, so the change in product concentration, okay, over the change in time, okay, because x here represents time and y here represents concentration of products. So here, when you, for example, let's say here it is 0, and here the concentration is, let's say, 2.0, okay? So, and here the time is 0, of course, and here it is, let's say, 1. So in order to prove to you what I explained, I'm going to do this calculation, which will be 2 minus 0 over 1 minus 0, which will be 2, okay? But now let's use this one. So here, let's say this is 1, this is 2. So here, let's say it is 1.2, okay? So 1.2 or something. And here it is, let's say 3, okay? Here it starts the almost exact same place too. And here it ends, let's say this is 1, this is 2, and this is 3. So 3. Okay. So now let us do the, this is 2 and this is 1. So this was for 1, and now this is for 2, which will be 3 minus 2 over 3 minus 1.2, which will be 0.6, like around that, okay? It's not very accurate. And don't forget the units. It is mole, decimeter, cube, seconds. And here, same thing. Okay? So here you can see that the reaction rate is way greater than here. Okay, now if you look at these two graphs, you would see that at some point the gradient becomes 0. Okay? The gradient becomes 0. At that point, or at that time, when the gradient, is 0, the reaction has stopped. Okay, so when, in other words, when the line or the curve becomes perfectly horizontal, that means that the reaction has stopped. Now there are two types of reaction rate. There is instantaneous rate of reaction and average rate of reaction. So what is instantaneous reaction rate? It is basically the rate of reaction, okay, at a specific time, at any given time in the graph. So if they tell you find the rate of reaction at 20 seconds, okay, let's say here it is 20 seconds. So you have to find the rate of reaction at this point. This is instantaneous reaction rate. And you should know that it is equal to the gradient of the line at that particular. Now, you might be confused from what I've written down here. You will not really understand it until we get to actually calculating the reaction rate. So let me show you an explanation to this. So let us say they tell you find the reaction rate at let's say at this point, okay? At this point. They tell you to find the reaction rate at this point. What you have to do is draw a tangent line perpendicular or at that particular point, okay, like that, and then draw a triangle like they did over here. So you take that line and then connect the lines, okay? You connect the tangent, okay? And then you form a triangle looking something like this. Now you can also do it this way. It doesn't really matter which way you go. You will end up having the exact same result as your with your calculation. But also remember that the calculations aren't very accurate because you can draw a triangle a bit bigger or a bit smaller. But you always have to just make sure at least that the tangent is long enough for it not to be touching the line, okay? So you have to make it long enough so that it's not touching the curve. Now you should also know, you should also understand this, that when you have a graph showing the concentration of reactants over time, okay, the gradient in this case is negative, which is why, as I told you, as I explained in the previous video, in the formula for reaction rates, you write a negative sign outside. Change in reactants, the concentration of reactants over change in time. You write a negative, or you put a negative sign outside because the gradient here is negative, it's not positive. Okay, now let's do an example. Let us say they give you a graph like this, okay? And they tell you find the rate, okay? Find the rate at 0 seconds, so at 0 seconds, and at 60 seconds here. So now how exactly do we calculate the rate of reaction at 0 and at 60? So let us start off by doing at 0 seconds, okay? At 0 seconds, we have to extend the triangle. Okay, I have to extend the lines. And here we don't need to extend them, we know already the exact values. So now we're going to, and this is a graph representing the change in the concentration of reactants over time, which means that we have to put a negative outside, like we have said before, and find the change in the concentration of reactants over the change of time in time. So it will be negative 0.6 minus 1 over 20 minus 0. So if you do this on your calculator, you will get 0.02 decimeter. Now let us see how we're going to solve to find the reaction rate at 60 seconds. So at 60 seconds, it will be negative. Let us extend the lines first. Now we will write 0.16 minus 0.43 over 79 minus 40. And you will get 6.9 times 10 to the power of negative 3. Then just write the units, okay? You'll get something like this. Again, it's not, your answer will not always be the same, because sometimes you might take the values not exactly like what your teacher might take it as, or your friend or your classmate might take it as. So it's like, it's fine, it's not always accurate. Here, and the second answer, you can also just rewrite it as 0.0069. Okay, now what about the average rate and reaction? Now for the average rate of reaction, it is basically the change in concentration. It could be of products or reactants, depending on the graph that you have, over time. Okay, or over the change, sorry, the change in time. The change in time. The formula for this is just y2, it's just like the slope formula. So in this case, for the average rate of reaction, instead of you finding the reaction rate at this point, for example, okay, at this point and drawing like a triangle and all that, here the triangle would be this. Why did we stop here? Because after this, the rate of reaction, the reaction has ended, okay? So the formula is just like previous. You either use negative change in concentration of reactants, okay, over the change in time, or just remove the negative sign if it is for the product, okay? So that was it for this lesson. Hope you understood. If you have any questions regarding what I covered, leave your questions down below, the comment section down below, or you could email me at educology.help@gmail.com. So in the next lesson, we're going to be discussing the collision theory and probably the factors affecting the reaction rate. So thank you for watching and have a good day.